Hi there everyone, very happy to see you and for your interest in learning more about Git and GitHub. This short lecture is part of the S2DS preparation to help you get ready for S2DS, to break into data science and start your new career. Maybe you're also looking to strengthen your general knowledge about software tools, and with Git and GitHub certainly being one of the most important instruments in the toolbox for any software developer or data scientists, this makes totally sense. Or maybe you already know Git and GitHub and want to see if there is anything new to learn. Let me tell you right from the start, this course should not be hard. But it is quite brief and condensed, so you do need to take it slow, and I recommend you do your own research on the various topics we go through. We will go through the motivation for Git and GitHub, what problems they solve, why Git is not the same as GitHub, and then delve into how to use it. Because this will give you the strongest foundation, I will go through the principles of Git and GitHub in parallel with some examples of usage. Understanding the core concepts of Git and GitHub will help you find your way around online materials, documentation, and so on. And there is, as usual with tech, a lot of jargon to get used to. I will show you the core commands and using Git from the command line, showing you the essential parts of the Git workflow. We will then proceed with some of the typical tasks you may need to do during your software data science projects and how to do those, including how to use GitHub to share your code and collaborate with others and how to undo things. Now, for those of you who heard about Git or GitHub already and are beginning with it, one of the biggest goals I have with these lectures is to take the fear away of using it. Some of what it does can seem like magic and obscure, and as it is directly working with your files, it can seem scary. But it would not have had the success it had if it would not be a tool that is extremely good at one of the core problems it solves, that of backing up your files and their past states. So showing how to comfortably and confidently navigate in your file structure and history is a key part. One of the problems Git and GitHub solve is that of backup. Losing all your hard work, your ingenious algorithms and deep learning models is not something you want to happen too often. I've certainly seen my share of loss of work due to various reasons, and having a system to help back up your work is important. It is important to understand that Git itself, when used on your own laptop, can of course not protect you from losing data due to theft of your laptop, a hard drive crash or similar. Now GitHub, however, does save you from that because it can maintain a copy of everything in the cloud on GitHub servers. So I'll show you how that works later in practice. Now, another thing is that one rarely works in complete isolation. Often you will work on a bigger coding project with others. And then the problem arises on how you actually share your current state of work with others in a very effective way. This becomes particularly tricky if you work on the same set of files as someone else. Now, GitHub allows you to share code with others and work together on the same project. Even when working on your own, if you are anything like I was in my early years writing software, it is amazing how quickly one can lose oversight over one's own project. Git allows you to organize your work better. Specifically, it allows you to organize working on different versions of the same code in parallel. Instead of copying files and renaming them by adding _experiment1, you let Git manage all these different versions for you. So that's another thing that Git solves for you. So it's these three problems that it solves for you: backup, sharing, and organization. Okay, I have been giving you a short bit of introduction now as to what problems Git and GitHub solve. Now let us get into using it. So if you go to the above URL and you have a GitHub account and logged in, you will see something like this. This shows you the homepage of this coding project, this GitHub repository, or repo for short. When you make your own project, the part in the lower part is the content of any README file you have as part of your repository, interpreted as Markdown. Many of the other tabs, buttons, and labels you see on this page, you will not use that often. So do not let all this information overwhelm you and distract you. Of main importance is the green button on the right, clone or download. Any project you actually want to work on, you need to do this for. Cloning here just means making a copy of the repository and storing it on your local machine. You cannot actually do this with a repository you do not own or are a group member of, even when it is a public repository. Rather, you need to first fork the repository, which creates a copy and places it under your own GitHub account, and then clone that repository from there, working on that copy. You then need to make a request with the owners of the original repository to incorporate your changes when you are done. This is called a pull request, and you may have heard of that before. Anyway, back to this repository. So to start working on this, fork it first by clicking on the fork button. Then go to your GitHub account, your own GitHub account, and find the repository. Then you need to clone it first by clicking on the clone button. Now there's two methods for cloning. The easiest is usually using HTTPS, but it does not work for all repos, and you're going to have to enter your credentials, password, more often than if you use the SSH method. I will not cover the SSH method here. The HTTPS method is pretty self-explanatory. Of course, in order to work with Git and GitHub on your laptop, you need to install Git as a minimum. There are many different distributions and additional tools, GUIs, etc. out there. I will cover here only using the basic Git with the command line. This, I think, makes sure you are close to the action and can understand better what is happening. GUI tools often do a lot under the hood, which makes it difficult to understand what is going on. Many of them are very good, and I'm not saying you should not use them. I will just not do so in this course. Once you have Git installed on your laptop, open up a terminal so you can use it from the command line, go to a directory you want to store the repository in, and type git clone and then the URL. This will create a new directory in your folder with the practice repository in it. To practice changing something, open the README and make some edits in it. If you then type git status, you should see something like this. This is showing you all the files you have changed. To tell Git about your changes and mark them to be added to the next commit, you type git add and then the file name. An alternative is to write git add -u, which will add all recently changed files. After you've done this, your changes are now what is called staged, earmarked for the next commit. You can see this with the git status again. To actually commit all earmarked changes, type git commit -m and then some message. The -m just adds a commit message that can be any text to help you remember what you did. You can look at a history of commits and the messages corresponding with git log. You can then see all the history of related activities with git rev log. Now, I didn't really explain much about what really just happened under the hood with all of this and what exactly a commit is. I didn't really explain either. So, let me explain how Git works some more now. I mentioned earlier that Git allows you to organize your code so you can easily work on different versions of the same code and switch between them. So how does Git organize code? All changes you make, starting from your very first file, is maintained by Git as a series of snapshots called commits. At each Git records the changes made to the code to get from the previous snapshot to this snapshot. This way, Git is really efficient with the way it stores things because every snapshot actually only needs to store the changes made to files rather than the complete file each time. These commits or snapshots then start to form a linear history of your code. As I mentioned earlier, to create a commit, you first need to stage the changes. Now, what exactly is that? Git first collects all the files with changes you want to bundle up into your next snapshot or commit. To mark changed files to be included, you stage them with the git add command. Once you have all of them together, you create your commit with the git commit command. After you have made a series of commits, you can then copy these commits onto the Git repository in GitHub, so they are accessible to others with the GitHub repository. So to do that, use the command git push. This pushes copies all the commits not yet on GitHub to the GitHub server under the repository. The opposite, which is to fetch any new commits from GitHub to your local repository, you can use the command git pull. This fetches the new commits and merges them with your work. Technically, git pull is a combination of a command git fetch, which just gets all the commits, and git merge, which merges them with your current work. I haven't really explained merging yet, so you may want to refer to this section after, later on as well. So let's go back to the organization of commits. As mentioned, Git commits form a history. These histories are called branches. You can always go back and forth between different snapshots using Git. There's a simple command to go to a specific past snapshot. What you can also do at any point is tell Git to create a brand new history branching off from your current branch, using the current commit as the starting point. This way, you can create parallel versions of your code with separate histories. Now, this is much easier explained with an example. So going back to the practice GitHub repository. Here, I'm working on the master branch, as you can see here. So let's say I want to start a new version where I try out putting a different formatting into the README. First, I create a new branch by typing git checkout -b new markdown, where new markdown is just a name I give the new branch. I then make my changes and commit it. First with the git add readme, and then with a git commit -m and then my message. Now imagine that someone else points out you should change the text in the version visible on GitHub, the default master branch. Now you don't want to change your markdown experiment, but you agree with the suggestion. So you can now go back to the master branch, which doesn't contain your markdown changes, and make that new change. To switch to a branch, just type git checkout and the branch name. In this case, we want to go back to the master branch. You can then make changes and commit to that branch, just like normally. And then you can switch back. git checkout new markdown. You can see the branching history like so. Git log and then -minus graph. Now you can apply changes made in one branch to another. This is called merging. Say, for example, that you want to apply the fix to the text also to the markdown version of the file. You can do this by typing git merge master, where master is just the branch you want to merge into your current branch. So note that when you merge in this way, you always apply the changes in the named branch to the branch you are currently working on. One of the most common problems with merging is that you frequently get merge conflicts. These are a normal part of the Git workflow and not at all a sign of a mistake or cause for alarm. Deal with them simply and methodically. They arise whenever two branches have had changes to the same file applied separately from each other since the branching occurred. Now, since Git cannot know which is the correct version, since both exist in parallel, Git leaves you to make that decision. The way Git does this is that it warns you of a conflict at the merge and then leaves a version of the file in your folder that has the contentious regions with the two versions clearly marked but has both of them in it. So what you then need to do is to edit that file so that it corresponds to the desired result and tell Git that you are done at the end by doing a normal git add, and then you give the file name which had the conflicts in it. So doing a commit then concludes the merge with the conflicts. So note that if there's no conflict, the merge will immediately create a new commit. So Git doesn't basically do this kind of stuff automatically if there isn't a conflict. It's only if it can't resolve it because the same file has been changed by two different versions and it doesn't know which one to pick, that it actually requires you to do this manually and you need to resolve the conflict. Now, commits where you actually merge two branches together have a special name and they're called merge commits. Now, one thing I should say is that when you work with others, you can end up with a lot of branches and it's important to get comfortable with this. Personally, I always found that the recommendation leave branching to the trees is a good one. Do not overdo it with the branches and make them as short-lived as possible. I have seen teams get in a real mess when working with several branches and then trying to merge them all back together after months of separate work. Git is a very rich tool and there is a lot to learn, but we are almost at the point where you know enough about Git to get started. One small topic remains, that of undoing work. What if you want to undo things? To undo an accidentally change in a local file so as to reset it back to what it was at the last commit, do git checkout and then the file name. You can also undo everything you have done since your last commit using the git reset command, but it's a bit easy to accidentally remove changes you wanted to keep. I never use this. To undo a commit, find the SHA code of the commit you want to remove using git log, and then use the command git revert and then the code. This will create a new commit that undoes your changes. It basically reverses the changes in the commit you wanted to undo. So note that it actually creates a new commit, a new snapshot, which does the opposite of what the commit did that you actually want to undo. Now there is another way to do this using a command called git reset, but git revert is what I recommend at this stage for any beginner because it is safe. Now, before I hope to meet you in person at S2DS, you should practice using Git a little. So here's some homework until then. Using the practice repository, you should create your own branch, add your name to the README. If you are the first, then maybe add a section like S2DS 2019 participants were here or something, and make a pull request. You can see here the steps you should get through to do this. Remember that this assumes you have forked the repository and cloned it to your machine. I have not detailed here how to make the pull request. Using Google to find these things out is bread and butter at S2DS, so I leave it to you for that. A hint, it's all done on GitHub repository page. Let me also leave you with a short list of extra resources you may find useful. Now, I really look forward to meeting you at S2DS and hope you're all going to enjoy getting started with Git. Thank you.